histogram equalization and histogram stretching. Now, histogram equalization basically helps to enhance the image contrast. Like, for example, this image is enhanced. This the contrast of the image is enhanced using histogram equalization. Now, what happens here is this will belong to one set of pixel intensity level. We expand that pixel intensity levels so that it spreads across the available range, and that helps to give us a lot of contrast. So let's see one example. Consider if I have these pixels and these are the counts. This is the cumulative count. So this is 1, 4, 5, 5 because this is 0. And so this is the cumulative count. I apply the formula. CDF minus CDF min. Min here in this case is 1 divided by total pixels 8 in this case minus CDF min. Total pixels is this 9. 9 minus CDF min, 9 minus 1, so 8, and the maximum intensity level is 7. So here I get, when I map for each and every level, that is for CDF level 0, that is for level 0, CDF level 1. Then next one is CDF level 4, 5, 8 and 9. I calculate the corresponding value. And now, as you can see here, earlier the values were ranging from 0 to the values were ranging that is at different intensity levels, and now it is at this particular level. So it will become 0, 3, 4, 6 and 7. So original distribution had values between 0 to 4, but now that level 1 value has shifted to 3. As you can see here, level 2 values has shifted to 4, level 4 has moved to 6, level 7 has moved up to 7. So now, because of this, that is an entire set of pixel range is covered, and that is why lot of intensity levels are getting changed and contrast is increased. So histogram equalization stretches out an image brightness level to reveal contrast and hidden details, and it uses fixes poor lighting. If there is poor lighting on the image, it exposes hidden data, spreads the pixel density over across the full 0 to 255 range. Histogram stretching, here it does not care about the pixel density, but rather it only looks at the absolute minimum and the maximum value, and this will use linear mapping equation. So here this has a slightly different formula. Here we will look at these different values are there in the image. So we have the minimum and the maximum, and then we calculate. We have 1, 4 and 2, as you can see. So now 1, basically it's 1 minus 1 by 4 minus 1 into 7. So here I will not stretch it, but rather I will do it on the core pixel values itself. Maps to 0. For level 2, it is 2 minus 1 by 4 minus 1 into 7. So 2.33, which is 2. And for level 4, it will be 4 minus 1 by 4 minus 1 into 7. And so it will be 7. So now this becomes linearly stretched like this. So in stretching, if we see, the scaling factor is a constant. See, every time it is minus 1 by 3 into 7 by 3. So here the scaling factor is constant. It's 7 by 3 in all the cases. So basically, histogram stretching, it takes the narrow range to fill the boundaries. That is, it takes the entire space is being used. Histogram stretching, it basically uh, changes the intensity levels without altering the overall shape. But histogram equalization, it tends to brighten up all the pixel values. So stretching spreads out the pixel values uniformly, but it maintains the original shape of the histogram. But equalization, it flattens the histogram completely based on pixel density. And so it aims at increasing the overall brightness of the image, whereas stretching is basically like increasing the number of colors that are there. It basically increases the intensity of the pixels, but equalization aims at increasing the brightness. That is the difference between the two. Stretching brings up, introduces more colors, introduces more variety of colors, whereas equalization brightens up the image pixel values. Always remember, stretching is a linear operation. Stretching does not alter the overall shape of the histogram, but equalization is a non-linear process, and it increases the intensity levels of all pixels. So histogram stretching is linear mapping, whereas histogram equalization is non-linear mapping. It expands a narrow range to fill the boundaries. Here, it will flatten out the distribution evenly. So this is one example of stretching where there are more colors that are being introduced. And here, equalization, it helps to improve the contrast. This is one another example of original image. This is histogram stretching, where you can see that unused pixels are being used here. And this is one example of histogram equalization, where it aims at brightening up the image. This is aiming at brightening up the image. Let us see one example through program also, where I first load the image in OpenCV, and then after that I calculate histogram stretching. Now histogram stretching, I'm calculating 2 second to 98th percentile to avoid outliers, and then this is the code, that is equalize hist will basically help me to uh, perform histogram equalization. Rescale intensity will give me histogram stretching, and this is finally the result after we plot it. So the same program can be done in OpenCV as well. I will include the link of this particular notebook in the description.